Hello everyone. We'll start today's session shortly till some more participants join in. Could you quickly confirm if I'm audible? You can type a yes in the chat box. Hey, thanks Mahesh for confirming. Just a couple more minutes and we'll start today's session. Good evening and welcome to today's insightful and future ready webinar, which is the power of large language models, how they work, and why they matter. So, we are thrilled to have you all with us as we explore one of the most groundbreaking advancements in artificial intelligence. LLMs or large language models. So, these models are transforming the way we interact with technology, innovate in business, and even create content. So, in this session, we will take a deep dive into how LLMs actually work, the cutting edge technology that powers them, and why they have become the backbone of modern AI solutions. From enabling smart chatbots to powering enterprise automation and revolutionizing industries like finance, healthcare, and education, LLMs are shaping a future that's more connected, efficient, and intelligent than ever before. And to guide us through this fascinating topic, we have with us today our esteemed speaker, Rushikesh Meherwade. Rushikesh is the founder of Vidvatta and currently also serves as Vice President of Data Science at Motilal Oswal. With over a decade of experience in data science, performance testing, NLP, natural language processing, and corporate training, Rushikesh has worked with leading organizations such as Capgemini and Renault Nissan, helping them harness the power of AI. He's a passionate educator, a mentor for top tech platforms, and a thought leader in machine learning and natural language processing. Um, so, before we begin, a quick note on how this session will flow. Attendees are in listen only mode, but you can submit your questions via the chat or else the Q&A tab at any time. And please remember, today's session is just the beginning. If you're looking to deepen your understanding of AI and machine learning, we encourage you to explore our AI/ML program designed to equip you with the skills and knowledge to thrive in this AI powered world. So, without further ado, let's dive into this exciting topic. Over to you, Rishikesh.
Hey, thanks a lot, guys. Just a quick check. Are you guys able to hear me? Guys, please help me by putting over the chat if you are able to hear me. Yeah. If you can just put it over the chat. Yes. Okay. Great. Great. Voice little bit low is what you're saying. Okay. Is it the case with everyone? Is anybody facing a challenge with my audio? Does anybody feel like the voice is low? Okay. Okay. Great. I think if some says clear, then I'm good. Okay, great, great. Awesome, guys. So, welcome back on this exciting session where we will be delving into the transformers, the large language models, which are something which are like changing the whole industry. The whole landscape of the AI has got changed a lot by the LLM models, like the large language models, which we are going to talk about today are going to have a lot like had a lot of impact, and even now they are creating a big impact in the whole industry. So that's what I'll give you a brief about myself. So my name is Rishikesh Merwade, and I have around 13 years of IT industry experience. Out of this, initial few of my years have been in the testing industry. I used to work in the testing industry. And then after the testing industry, now, like after 6, 7 years, I worked in the testing as a performance testing, uh, the functional testing, different type of testing I used to work in. And then we saw that data has become a very important part. So with data, like everywhere we used to see data. So there I wanted to understand and learn about the different methods which were at that point being discussed around the data. Some of them were like big data analysis, data science. All of these were like hot trend around 7 years back. Then we had the deep learning. Now it is more of Gen AI, all of that. So after like 7, 8 years working on the testing domain, I got to see that okay, there's a data, something that is coming up. There was a big data center. And every year I used to procrastinate that whether I should learn, not learn, how to learn. Because one was a example, what used to happen is there are so much content, it used to be math heavy. Python is something which is very math heavy. There are so many algorithms to learn around. So around that time, I had to go through the program by Great Learning, which was Business Analytics and Business Intelligence. It was one of a program which was there by Great Learning around 7, 8 years back. It is still there with a different name now. And we used to have R at that point. So that was a 1 year program which was there for okay. Guys, like is anybody else facing audio issues? I do hear by some people that there are audio issues. Okay, okay. Just give me a second, guys. Yeah, is it better now? Like, are you able to hear me better now? So,
Rishikesh,
like,
yeah, you are
like,
audible. Yeah, yeah. I can hear you clearly, Rishikesh, loud and clear.
okay, great, great. I think I'll go with the camera off for now.
Yeah.
Maybe I'm facing some internet issue. Okay, great. So let's go ahead. So what we're saying is, let's go through the power of LLM. So let me share the screen and okay, guys, again, I would need a quick confirmation from you all that whether you are able to see the screen or no. Like all of you are able to see the screen. Perfect. Great. So I would like to ask to all of you, what is LLM as per you? Okay, all of you must have heard about this LLM. So what do you think? Can you tell me in few words that in put it over the chat, what is LLM as per you? Okay, whatever you think, nothing is right and wrong. What you feel, uh, you can let me know. What is LLM as per you? Yeah, guys, I hope my voice is clear and you're able to understand the question. So I'm asking, what is LLM or large language models as per your knowledge? Okay, Venkatesh. LLMs have capability of NLP and reasoning. Okay, great. That's good. Anybody else would like to add? Okay, so one is we are saying capability for NLP and reasoning. Anything else? LLM is models having more billion parameters. Okay, that's great. Bharat, LLM is capable of reasoning, analytics, and text matching. Okay, great, great. That's great, Manas. Great, Bharat. Pritesh says it understands and generate human-like texts. Okay, awesome. Pritesh, that's good. Great. I think let's understand what is LLM in terms of a definition level. So advanced artificial intelligence model. Okay, that's good, Naneshwar. So LLMs are the advanced AI systems which are built on top of the neural networks or a deep neural networks. Okay, and within the deep neural networks, we have one of a type of a model. Like we have different type of models. There are artificial neural network, there are convolutional neural network, long short-term memory based network, GAN based network. So one of a type of network is called as a transformers. So transformer was something that started around 2016-17, where Google started with a paper called as Attention is All You Need. So that paper started with a revolution where there was a new type of model. Right. Example is BERT, which on top of the transformer, they built the first model, which was BERT. Like from that, a lot of transformation started to happen after that point. So these transformer models, now in neural network, when we build the neural network, there are neurons. Okay, these neurons are a small knowledge. Okay, these are like there are individual neurons. The way we humans have in brain neurons, like billions of neurons. Okay, all of these neurons are again connected to millions of neurons. So what happens within these neurons is there is a good computation that is happening. For example, within our brain, we have different sections. Like when you're looking at something, there are some visual cortex, which are a group of neurons which helps you to visualize things. There are motor cortex, which is a group of neurons inside the brain, which takes care of movement related aspects. So within our brain, as a humans, we have different neurons, which takes care of different activity. Similar thing, scientists thought that, okay, how can we bring in this kind of a structure to learn the data? So that's where this neural network comes in. And this individual piece of small knowledge that is learned inside, which are neurons. Like this new transformers, the large language models have billions of parameters. Okay, these parameters are nothing but the neurons. Okay, so you may have heard of Llama 7B, 3B, 1B, 120B, or even like 70B. This model comes up with this B as a parameter. So there are 70 billion, 3 billion, 1 billion. That basically defines what is the capability of that model. The more are the neurons, the higher is the capability of this model. There are just different type of model, right, Bharat? So we have mixed GPT, we have like Llama. Okay, there is a deep sea. Right now there is a Quen. There are just different companies coming up with the different type of models which are based on or trained on a large corpus of data, and those we call as a large language models. Okay, we will again try to go through this in a detailed way. So they understand it generates a natural language ranging from full sentences and code to symbols and images like emojis at a scale. So this LLMs, just one thing to add is that LLMs are nothing but a next to word predictors. Okay, so when we talk about learning, deep learning or even machine learning, we talk about learning mathematical structures like the linear algebra, probability, statistics, calculus. So one of the things that works internally is this large language models are trying to learn the complex patterns of words. Okay, how these words are related to each other, how the next word is going to come based on the different type of words which are going to be present. We as a humans do it so easily. Our, like we don't think much like what word to use. Our brain is able to generate that next word easily. In the same way, LLMs or large language models are just a next word predictor model. They are learning a complex functions which helps us to identify based on the given set of words what is the next word. So they are trained on a huge corpus of data. Like whole internet is used to train these models, and then within that they just learn the pattern that okay how these words are going to be sequenced one after another. So these models learn how to predict the next word, and within this activity we are able to train this model to not just learn natural language, the way we speak any type of language, but we can also train it to code. Like even the programming language being one type of a language, even we have trained this large language models to learn the code. Also, these new age things like emojis, any kind of symbol, these models can learn any of it, any of the sequential things. It can learn and do a predictions for. So in terms of different capabilities which are there with respect to this LLM model, one of a core capability, the one of a very core capability is the generative part. So as we all talked about the next word predictor capability, right? So this next word predictor capability gives it the power of generation. You have seen that when you try to put in ChatGPT a question, it gives you word by word response, and then based on that, it is able to generate something. So the thing that I mentioned to you, that large language models are a next word predictor. And then based on that, how the essay or any kind of thing or report is generated in ChatGPT, it makes a one word prediction based on the context that you give. That word is again given as an input. Again, it tries to use that as the input and again predicts the next word. Again, this new word is used as the input to predict for the new word. So like this, it keeps on generating words one by one. That's what you see in all these tools. Those word by word output that you get in ChatGPT are not for the animation purpose. Okay, they are not like just for the animation word by word outputs are coming, but that's actually part of this model where the models are generating the output one by one. These are also called as a token. We don't call them as words, but we call them as a token because there's a slight different structure internally that goes into it. So rather than word, we call them tokens. On top of it, the breakthrough that happened with respect to the transformers and the self-attention plays a very important role. As I said, this transformer, when they came in, this gave a power where we were able to train it with a large corpus of data. What used to happen with the earlier level neural network models was they were not able to go beyond certain level of data. Even if you create a big model with multiple billion parameters, this model were not capable of going for one, like after a level, they were not able to go beyond. So because of that, what really happened was we were not able to scale large. But when the transformer model came in, it gave us a power that we can also increase the size of the model. We can also increase the data to the model, and we can keep scaling bigger and bigger. That's where you are seeing that now these models are not stopping, and every level these models are keep growing because these models have this capability. The transformer have the capability that they can keep adapting with more data, more resources, and people are also making a lot of changes in the transformer architecture also to get a new and new models keep on coming. It has this capabilities of scale. As I again mentioned, the scale, there's no scale, like there's no limit to it. We can keep increasing the data, we can keep increasing the model size and try to learn. But now the challenge that has happened is we have exhausted all the data, but now we don't have a lot of data, but the data is we are already exhausted. Now the companies are trying to make the work on the architecture that okay, how we can make any kind of changes to the architecture. So we can learn something better out of it and more out of it. And it has a capacity to do the compression of this universal compression of the language. See, we as a humans struggle with few languages. Okay, we can go to two language, three language, four language, but some people are even good with okay, five, six, seven languages because they work with that. But LLMs are able to learn lot of languages. It's not just few languages, but we are training them to learn lot more complex and multiple languages, right? So it has a universal language learning capability where it can just transform to multiple languages learning. Guys, like if you have any questions in between, please put it over the chat. Don't hesitate to put it over the chat. Okay. Anytime you have a question, please put it over the chat. In between, I'll be able to go through it and answer if any I can answer immediately. Okay. So this models is again like yeah. So I'll come to that. Yes, I'll come to that part also. Okay. So Bharat, I'll summarize the LLMs. Yes. So LLM is basically a type of the AI designed to understand and generate the natural language at a very scale. Like we are able to generate the natural language at a big scale because now we can generate books, we can ingest books, we can read books, summarize the books, or even generate a book level content. So this LLM are built for doing a scale, like multi-scale things. These models are trained on billions of parameters and a vast amount of data, enabling them to predict, interpret, and also produce more like a human level information. Now, what language in the system do this LLMs actually understand? Can we call the same as bird? So, Bharat, like the Bharat question is, can we call the similar to the bird? Bird has some limitations. With bird, what happens is you can't generate a lot of content as an output. Okay, you can generate a limited content as an output. There are now encoder models and decoder models. Within LLM, within transformer, we have categories of this encoder and decoder models. BERT used to be an encoder model, which was good at learning the content and just giving only a small amount of information. It doesn't use to generate a content. Okay, but these are LLMs are more of decoder based model. Now, what happens with the decoder based model is they can generate content. They are not just limited to understanding and answering only some part of it, but LLMs can generate a continuous predictions like continuous paragraphs, books, lot of that. BERT was not capable of that part. Okay, so that is the difference between BERT and the LLM-based model. And BERTs were very small; they were not that big. So extension of BERT has happened in terms of the overall compute size and the type of output that we can generate. BERT were very early type of models only used for prediction, word level prediction, token level prediction. We only used to do that at a prediction and also generating a short output from that. The BERT was also used to do translation based output, but that was only again limited kind of a translation, but you don't get to generate content. Okay, that was the main difference. So LLMs can go beyond just a spoken or written human languages. Okay, it's not just limited to the language as we are saying. They are going beyond that, where it can be music generation. You can also generate a mathematical equations. Okay, again, these are like complex things that we as a humans take so many years to learn. Like we spend so many years in the school to just learn the mathematical equations. Okay, but the computer programs can learn those as a sequence of activity. See, when we try to solve mathematical equations, those are also sequence of activity. We try to deduce something. We start with like, okay, one equation, we try to break down, and then try to solve it step by step. So LLMs can also learn to solve these equations step by step when based on this next word predictor approach. Musical notations. You may have seen there are different models which can generate the musical output. We can generate the videos as output. Anybody knows what type of models are there for video generation? Have you guys heard of video generation and any model that you know of? Okay, good Bharat. One is the Sora by OpenAI. Anything else? Right, Vaishnavi? Sora is one of a well-known model by OpenAI. Okay, there are again, Sora is one of it. The Gemini also recently came up with VO3. Okay, you may have heard of VO model, which is generating the video plus the audio. Sora is mostly limited to only generating the video, but the Gemini model that came up has also video and text, sorry, the audio generation together with that. So there is also Runway AI. So there are multiple different models which are there who can also generate a video. So any type of generation with respect to the data, for example, text, images, videos, audio, all of this unstructured data. This we call as unstructured data because these are not structured. And we call this AI because we as a humans are more involved in this kind of data. Okay. The tabular data, structured data is more for machines to understand and simplify, but we as the humans understand this complex AI data, and these models are able to handle that. That's where we are more interested and call them as AI because all these models are capable of handling this complex data. That's where we name them as AI. So that's right, Bharat. Like VO3 is one. We have Hunan video, yes, Van Hunan. So these are like multiple different models which are there for generating the videos. Okay, so same way, many companies are also using it in a custom level to generate internal. So there are many companies who try to generate some kind of internal codes. So they use LLM models to learn this codes as a representation. Okay, so these LLMs are not just limited to this, but wherever you see that there's some kind of a generation, a token by token, or some kind of a sequential output is need to be generated, there the LLMs can be fine-tuned also to use on your own custom data. So chemical and genetic codes. Many companies have also used this to generate the protein structures. You may have heard of AlphaFold. So AlphaFold is one of a model which learns the protein structures from the different type of sequencing data. Morse codes, cryptography, images, symbols, traffic signs, haptic signals, different communications from the humans, and artistic expressions like dance, videos, all of it, we can generate using the LLM based models. Some are already available, some can even be fine tuned for your own custom applications. Okay, so how do LLMs actually understand language if they are just predicting the next word? So Vaishnavi, based on this complex, like when we say billions of parameters, okay, that's a very good question. So what happens is the billions of parameters which we are learning, they are trying to learn the language. They're all just trying to understand the language at a complex level. These models, some are small, but let's ChatGPT and all kind of models, they can't even be fit into one single GPU. We need multiple GPUs who even have like 80 GB RAM, 100 GB RAM of GPUs, and we need multiple of those to just host a one single model. So you can understand the complexity level of these models. So they are this complex and trying to understand lot of different relationship between the model. So when you give it a sequence of words, it is going through this LLM model, and this LLM model has learned the whole history of language. Okay, all the language it has learned and remember. You can think of it as like a big machine that has learned all the word related combinations. Okay, every possible combination of word sequences, it has learned from its history. And now, whenever you give it a new text, it knows that, okay, it doesn't understand the grammar or anything. It just knows that, okay, these are the sequence of words in the history. Whenever these kind of words were coming, next word had this kind of a probability. It will try to calculate the probability for every single word. That, okay, given this set of words, what is the probability of a next word? It has almost like 30, 40,000 of words. And every step, it tries to predict what is the highest probability word out of this 40,000 words that it has. Okay, so it tries to just define the probability at every step. We think of this as a language understanding, but internally it is nothing but trying to understand the probability at a language or a word level. Okay, great. Cool. Now, see, in terms of LLMs, there are many different companies who are working to provide the LLM models right now. So we can categorize these LLMs into multiple labels. First label, we can categorize them as paid versus open source. Okay, can someone name the paid source models? Okay, can you guys name the paid the paid LLM models? What do you think? Which are the paid LLM models that you know of? Okay, great. So, uh, Siva Bharati says Copilot, Manas says ChatGPT, Lambda, Quen, okay, Gemini, GPT, Venkateshwaran, uh, Vaishnavi says OpenAI, GPT. Okay, see, so the three top, I would say first top, the three top paid source models, the paid I'm saying are like they are not available open source. They are just paid. You just can access them through the paid structure. Is one is a GPT, this GPT-5, GPT-4. This is a paid one. You don't have any open source alternative to this. We have Anthropic, Claude-based models. You may have heard of Claude 3.7, 4, Haiku, Opus. So one is a Anthropic model. Third is the Gemini model. Okay, so Google Gemini is also a closed source or paid API access only model. Okay, they are purely available as a paid model. You can't access them anywhere. The second type of models are open source model. This open source model can be available paid and open source both. If you're comfortable to host it on your own local or your internal servers, you can do it. Or if you want the server, like somebody to provide it, it is also available. So for example, Llama is fully available open source. You can host it on your own systems and access it without your data going outside. Mixtral is available open source. Quen is available open source. Okay, these are like some of the now Google gives a Gamma as a one of the open source alternative models. Okay, Gamma is also one of the open source alternatives. There are many different models which are open source, which are you can directly host in your own system and run them. Okay, so one is like open source, which are fully available to you. You don't need to pay anyone. You can host it and run through it. Other is they are paid. They are not available anywhere. You only can access them through this providers. Okay, this companies have hiding their like they have kept it as hidden behind their APIs so that we can only access them through the APIs. So Palm is one of a earlier version of the uh, Gamma model. Okay, Gamma Gemini Palm was something open source earlier. Then the Google came up with the Gemini name for the Palm. Ford was one of a old model. Lambda was also one of a Google initial set of models. Okay, again then Quen and all of these are others. So DeepSeek also you must have heard of. So DeepSeek is also one of a model. Uh, which is an open source version. You also get it paid and you also get it open source. You can host it in your own system. These are like some different types and categories of model. Now, as a type, if I have to say, this model comes up with multiple variants. If you go for GPT-5, GPT-5 will come as a nano, micro, and large. Okay, there are like three variants. I may not have the exact names, but even within that, you have some fast but less accurate, slow but high accurate. For example, in Gemini, you will find Flash as one of a model and Pro as a one of a model. Okay, like for example, 2.5 will have a Flash which is a faster but less accurate to some level, and 2.5 Pro, which is slightly slower but more accurate. There is also reasoning models. So reasoning models, before giving some kind of a response, they will try to reason and then give you answer. Okay, so there's also reasoning as one of the models that you will see. Now again, some more things are coming. You will find out that this models comes up with a deep research, canvas, also agentic mode. There are a lot of different options which are available now. Okay, so if we have to talk about how these models actually work, it's a combination of neural networks and machine learning working together. Machine learning gives us a concept of how do we learn from the historic data. Machine learning provides us a way by which we can create a models which can try to create a prediction based strategies from the given data. Machine learning is good in terms of extracting patterns from the data, and these patterns can be leveraged over the future. So in the LLM based structure, machine learning enables this model to predict the next word based on the context of the previous words. Whatever words are in the previous context, it is used to make a prediction for the next set of words with the machine learning. Whereas neural network acts as a brain of the model. Okay, learning from the massive data sets over the time. Neural networks also identify the pattern, grammar, tone, domain-specific language, all of it. So neural network, this complex structure of the neural networks allows it to learn patterns, grammar, tone, domain-related aspects, all of it, the model is able to learn. This continuous prediction refinement loop builds coherent and context-aware outputs. Okay, this context-aware output we are able to generate using the machine learning-based strategies. Now, as we talked about the transformer, right? Like LLM uses transformers to process the inputs more efficiently. The main goal is how do we learn the complex structures of the language? For example, see now whatever I'm talking about, what you all know what I'm talking about is about the LLMs. Okay, even if I don't repeat this LLM as a word again and again, you in your back of the mind know that I'm talking today's session is all about LLMs. This kind of structure we were not able to train to the previous generation model before the transformers. Okay, this memory, this history of understanding that okay, what we are talking about. This is called as the attention. Attention is all about how do we attend that okay, the current word that you're talking about is all about the LLMs. The current context is all about LLMs. This kind of history and memory we were not able to learn based on the previous models. But now with this transformer, we can attend, like these models can also learn a longer context. For example, even if you give it a book, from the book, it can easily correlate information. That if something is talked about in the first page, and that again is being repeated over the 7, 8 page, transformer allows us to create that relationship that okay, this word which I'm talking about here relates to the first page. This kind of relationship the transformers are able to capture. That's where we can do long, lengthy conversations with the LLMs. It allows a model to weigh the importance of each word in a sentence, not just sentence. As I'm saying, it can even go beyond the sentences, it can go beyond paragraphs, pages, and it can attend to the importance of the individual words, similar to how we humans try to infer the information from the given context. Now, transformers also allows us one more capability. They are faster. They also allow a parallel processing of the data, improving the overall performance and scalability. Now, as I said, this transformer model that we host, like the GPT model, is hosted over multiple GPUs. One model is hosted over multiple GPUs. But to do this, this model internally should have this capability where they can be parallelly executed. Okay, transformers internally have this capability where they allow a parallel processing. Okay, multiple queries, even if we try to give as an input, this model can run parallelly, and by the parallel running, they can achieve a lot more outcome. Okay, that's where the transformer also are more better because like when you're training it, we're training it with the GBs or TBs of data. Okay, these LLMs are trained with the TBs of data. If you run it on a sequential processing machine, it could take like months or like multiple months of time. But these models can handle parallel processing. That's why we can run like within the days. Like this, all the big models that you will hear about will be trained on like 7 days, 10 days, like only like in the number of days rather than months, because they are running over the parallel computation. Yes, we need the GPUs. The GPUs actually makes even more possible that we can run them multiple parallel ways. And transformer also, transformers plus GPUs together try to give us this superpower where we can run them on a parallel basis. Okay, so whenever we are making a text generation predictive activity, we have a user input. There's a concept of tokenization. I mentioned that we don't call words, we call them tokens in the LLM space. Okay, I'll not go more into it, but tokens are a way by which LLM tries to understand its own tokens. Then we have the context analysis, which is done by the transformer, where it tries to understand every possible word, how that word relates to the other word before it makes a prediction. And then the prediction loop is run. I mentioned earlier that it does a word level prediction. So one word is predicted, Then that word is again fed as the input. Next word is predicted. That word is again fed as the input. Next word is predicted. So like this, one by one, the words are getting predicted. They're again being fed back in the input loop. So this is a loop. So in a loop, we are trying to continuously generate the text. So key milestone, the initial language processing systems were very simple in nature. Okay, the first chatbot was created by Joseph Weizenbaum, simulating a psychotherapist in the conversation. But these conversations were very rule based. In 1966, the computer systems were very simple. We were not able to do much. Those were rule based, keyword based. We just used to understand the keywords, and based on that, the activity used to happen. Okay, then around 2013, we had a word to vec. This word to vec transformed the way we understand the language. For example, see, when I'll just take an example of bank. Now, bank as a word can be used in multiple places. The bank as an account would have a different meaning. Bank in a river bank will have a different meaning. Okay, but if I just use a bank as a word, it may not represent that context. But we need, like we as a humans, when we talk about bank, we have multiple things going in our brain. It's not just a word for us. For us, it's a lot more than just a word. Because in our brain, if you just think of any word, you have a pictures, you have some stories, you have some representation that is stored in your brain around that word. Similarly, with the word to vec as one of a model, we were able to create that kind of a structure for a word. It started around 2013, but then that concept was again extended to give every word some kind of a meaning than just representing it as a word. Then around 2018, like 16, 17, we had this concept of attention is all you need. That was a transformer. And then around 18, we had this GPT, BERT, all this model. Like there are many models. Around the 18 time, there was a Alberta, GPT, BERT. These are all different type of models which came around that time. GPT being generative, pre-trained transformer. As the name itself says, these are transformer-based model. They are pre-trained. Pre-trained means it already has some kind of a training done because it is already trained on a vast amount of data, and we are trying to utilize it on top of it. So it's already pre-trained, and we are trying to work on top of that trained model. Otherwise, when we in industry create any model, we train it from the scratch where it is blank, and then we try to create on top of it. But these models were already trained, and then we are using directly this pre-trained model. And generative says that these are generative in nature. Okay, generative AI, when we say these are generative, they are able to generate certain things. BERT was a bidirectional encoder representation based on the transformers. This was BERT was like a very early stage model, which gave us a lot of hope in terms of what can be now done with the transformers and advanced applications with respect to the NLP. So BERT significantly advanced the state of the art in NLP based understanding tasks. In 2020, GPT-3 came in, which just changed the whole landscape of the, it gave power to everyone. Like the whole general public also was able to get the power of AI. Before to that, AI was only limited to some people. But with the GPT, the AI got like commoditized. Everyone was able to use the AI now. So a model with like a 175 billion parameters, achieving like unprecedented level of language understanding and generation capabilities. Then 2022, we have this Chat GPT. Now there is a difference in Chat GPT versus GPT. Okay, internally, Chat GPT is like an application which is built on top of the GPT based model. When we as a application programming, we try to use any model, we use the GPT model. Okay, Chat GPT is like an application on top of the GPTs, which has a lot more capability. But internally, the model that is used is a GPT, which we also use to build different type of applications. Okay, so GPT 3.5 was the model, and the team came up with the Chat GPT, which is more refined version on top of the GPT 3.5. Lot more things goes from transforming the GPT 3.5 to the Chat GPT 3.5. Nowadays, we have this GPT 5, which is again newer version which is available.
So GPT-4, we also now have GPT-5. So in terms of capabilities, if we talk, there are those different capabilities that which are there with respect to this. We can generate text, we can generate code, we can do translate the text from one language to another. We can summarize a big information into a small scale information. We can also understand the sentiment of the given text. For example, is there any happy thing, sad thing, what is being discussed about? All of this is also very useful in uh, the customer analytics and all, where we try to understand what the customer is talking. Is the customer happy, angry? We try to understand that. Dialogue-based system, and it's all about the communication, chat-based system, bug detection, etc. The GPTs and all are used by co-pilots, Claude Code, you may have heard of those, the GitHub Copilot and all, cursor-based ID, which goes in extra level to understand the text and do the bug detection in the code. If we talk about some of the real-world use cases, we can do a product description generation. You just give it a prompt, and based on that given prompt, the ChatGPT can just give you, the GPT-based models can give you the whole description about the product. Not just that, you ask it to generate your brochures for a given product. You just have a simple idea in your mind, but from that idea, getting like a full-fledged product, marketing idea, selling idea, generating the website, you can generate everything nowadays. But first, you need to have that vision. Once you have that vision, using ChatGPT as an assistant, you can generate a lot more complex applications. So when we learn about AI, the learning part of it is how do we build custom applications like this? ChatGPT is more of general. Okay, it's like a general purpose application which can do everything, but it doesn't specialize in anything. But when we build our own custom application using these models in the backend as a programming language, we try to generate a complex applications on top of it. For example, let's say I want to automate a marketing operation for a given company. Using the chat GPT as the API, we can create our own custom prompts and build a whole marketing pipeline. Where from the given problem statement, we can generate the multiple images, multiple taglines, try to send it to a user for review. User will pick some of it. We also send it to the social media. On social media, the agent is going to take care of responding to the people. So a lot more things we can now build in a custom level using the GPT-based models in the backend, not just GPT, but any type of LLM model. Code snippet creation, bug label detection. Okay. Also, like doing the language translation also plays a very important role. Nowadays, language is not a barrier. When you go in foreign countries or even in India, when you are trying to go to cities or places, the language that you may not know. Some of the ways I have dealt when we went to some outside countries, we were not getting the language. So what we used to do is to talk with local public. We used to go with the Google Translate. We used to talk. We used to provide the text. We used to get the translation. We used to show directly to them. They used to again type back, and we used to get the translation. So language is not a barrier nowadays. We can easily communicate with people by the multiple translation based products which are available. Paraphrasing and rewriting, this also plays a very important role in the industry. You have a meeting recording, and then after the meeting, you get a complete paraphrased with the key activities. For example, there are multiple meeting bots nowadays. For example, Zoom has a bot. So end of the meeting, it will just go through all your text, try to come up with the whole summary and give you the pointers that, okay, this is what is discussed in the meeting. These are the pointers. These are the tasks which are available. So paraphrasing and also rewriting of the whole text. You give it a text and say that, okay, let me transform this text now for a PPT. You have a document. From the document, you say that, okay, now transform this document for a PPT. Transform this document for maybe LinkedIn post. Transform this for an Instagram post. Things like that, we can easily paraphrase and rewrite it. As there are also good things, there are also some bad things which we have to manage with respect to these LLM models. One is the hallucinations. this model sometimes may go beyond and try to provide answer to the thing that even it may not know. Okay, we as a human sometimes we accept that okay, I don't know this thing because it is not there. But LLM don't do that. They try to come up with its own output, and that can have a challenge in the actual application. So we have to manage that. Bias and ethical challenges. These models are trained on the information that is available online. And the information that is available online can be biased toward races, religions, or gender label bias, political bias. So there are different type of bias which will be present in the data. So the same bias also is learned by this model. So we have to be careful when we are trying to use this model that the customer is not getting any kind of a bias. For example, if there's a female talking, and because of the gender bias, this model is now responding to them as a him, then that could be a challenge. So we have to handle it explicitly when we are building applications on top of it. Okay, domain mismatch. You may have that, okay, you're working with the health tech domain, but it may not have very much relevant information for the health tech. Or maybe you are working in the manufacturing and it may not have all the relevant things related to the manufacturing. So it may have some domain related mismatch. Technical limitations, all of this is like a word prediction. So difficulty with the rare words which are not present. Just an example, let's say in your company, you have Smile as a product. Okay, there is a short form. Your company may have a long form for the Smile, but internally you say that, okay, I will be going with the product name of Smile. Now, if you try to ask your LLM anything about Smile, it may not know about your smile as a word. It may come up with something different, the real meaning of the smile. So how do you handle that? So that also is a technical challenge which will come. Real-time translation challenges. The systems are not very good in terms of uh, fast real time. If it's a large thing, then you may not get a very fast response. There will always be some type of small gap which would be present. That's a considered thing. But again, when you build applications, we have to understand what is the latency expected. Is it to be possible to be developed with the LLM or not? Okay, scalability and environmental challenges. These models are big in size, and because of the big size, the scale is a challenge if you're hosting it locally. So that plays a very big challenge. If you talk about the future, predictions for 2025 and beyond is there's just so much of rapid change which is happening with respect to the LLMs. There are a lot of use cases which are coming which can help us build the smarter applications. Conversationally, these things are going good, but we have to also understand around the human values, responsible use of the AI, like expecting the workforce reshaping with the Gen AI, where like the work that we do is going to be integrated fully with the work. Like a lot of things are getting automated, and we as the humans are able to scale things much faster now. People who are good with AI are able to achieve their work much faster. Gen AI in productivity. Gen AI is also being used to drive the productivity. All the productive people, like they're able to increase the productivity. In case of art also, like a lot of artistic things, these models are able to generate. But it helps the human to ideate, do works much faster. So a lot of different productivity impact we have. Democratization of the AI now. Everyone can use the AI. Every hand has access to the free AI use. Ethical and workforce related shifts. Okay. So if we talk about the future, some experts say that it will be the year where conversations gravitate to Gen AI and ethics and what it means to be a human. We'll more understand that, okay, how we as the humans could be different as compared to the machines. Okay. So the overall key takeaways, I would say, is like large language models are being used across the industries, be it customer service, content creation, marketing, software, manufacturing, any area you name it, everywhere the Gen AI LLMs plays a role. They support automation and innovation by generating human-like languages. LLMs can produce some biased, accurate responses, so we have to be very careful with that. It's important for the organizations to use models thoughtfully and also responsibly. As LLMs continue to evolve, professionals need to stay away from their potential risk and long-term impact. Okay, so let me quickly just talk about the program and then I'll be able to take the questions. So with Create Learning, we have this 12-month program, which is having a flexible structure. It's a combination from Great Lakes and UT Austin. You will be getting a peer-to-peer learning, immersive hands-on learning, and it is ranked as #1 program for like 5 consecutive years. You have faculty from different industry level experts, like academic experts and also industry level experts coming together to build a great program. In terms of the curriculum, the foundations and like you get foundational learning and also self-paced modules should be available to learn. There are a lot of domain-specific exposure, lot of different tools available to learn from. There are many examples with respect to the career hikes. If you have any questions, you will be able to get to the team based on the details which are available here. On top of it, the team has also shared a feedback link over the chat. You can use that to fill your details and team will be able to get back to you with support. If you have any questions, please provide your feedback over the link and team will connect with you for more details. Now let me go to the questions. So guys, like I'm open to the questions now. Whatever questions you have, you can put it. So Vaishnavi asks if transformer process data in parallel, how do they still ensure the sequential flow of meaning in natural language, especially for larger text? So that's a good question, Vaishnavi. So see what happens internally, architecturally, there are a lot of pieces that happens. These models are broken down into smaller chunks. Okay, this big model is broken down into smaller chunks, and a lot of parallel processing happens to get you the output in a much faster level. But when we say they are parallel, they are able to like these models are so big, right? So sequentially, still there is one type of process which is going on. But even generating this every single word, there is a lot of computation. So we are talking when we say parallel, even generating this one word, lot of parallel processing is happening to get us one single token. If you think of this 30 billion parameter model or like a 170 billion parameter model, every word goes through this 170 billion parameter model. So going through that, it takes a lot of operations. So parallel, when we say one word going through this multiple different neurons, lot of parallel processing is happening in the backend to make it much faster. Okay, I hope you get that part. So Bharat, like what is the difference between Gen AI versus LLM? So Gen AI is the application perspective from the LLM. Okay, LLM are large language models. Now LLM could be limited to text because of the large language part that we say. But now in terms of generative AI caters to videos, text, images, audio, everything. So generative AI is anything that is able to generate used on based on the AI. And LLMs are a tool. LLM are a tool which are used internally to power these Gen AI applications. Okay, I hope I'm able to add to that. Prompt engineering is a way to use the Gen AI. Okay, prompt by providing the prompt to the machine. See, prompts are more of a communication. Prompts are we are trying to talk with this Gen AI. So we talk, they understand the language. These GenAI models are good in understanding the language. So we try to provide the prompts as an input. And this GenAI understands these prompts as the input and generates an output based on that. Okay, so GenAI takes the input as a prompt and generates output from that. GenAI goes hand in hand. Yes, they go hand in hand. That's right. All of these things are connected with each other. GenAI, prompt engineering, LLMs, agentic structures, okay, RAG, you may have heard of it. So all these things are connected to each other. There is an overlap between them. Okay, so thanks a lot, guys. Like I hope I was able to provide a knowledge to you all. Okay, I hope it was helpful to you. Uh, I'm hoping that I was able to add something knowledgeable to you which you already had. Sync agent to do all this info. So agent, just to add, I would say agent are one step beyond. The generative AI only generates things. Okay, generative AI only generates. Agentic talks about how can we go to take action using this LLM. Okay, action means browsing the web is not internal part of the LLM. LLM can understand the context or a text, but browsing the internet, trying to get the context from the internet and then trying to again study on top of it or understand on top of it is more of agentic. You give access to your database where the LLM will say that, okay, give me access to the database. I'll fetch the data by myself and work on your data is again agentic. Okay, so agentic is on top of generation. You also try to take some actions. So it's a more action-based generation is the agentic AI. Okay, so there's the prompt engineering, RAG, GenAI, LLM, agentic, memory. Uh, there are just many different pieces, which is in itself the course in itself. Okay, to understand through this, but yeah, a lot of different words you will be hearing. There is the MCP, there are tools. Okay, so these are all like different terminologies which are there. Yes, the confusion is there. Yes, but once you go step by step, you try to understand them one by one, it will become more clear. When you look at only the words, they may confuse you, but everyone has a word to play. Okay, so Bharat, I think, yeah, within here, see, if I have to tell, I would not say there is a hierarchy in this. See, they all have a overlapping architecture. Okay, prompt and LLM and GenAI, they all overlap with each other. There is no hierarchy. I can't say LLM first versus prompt first. Okay, so just a plain hierarchy would be prompt. Prompt is going to the LLM. Both of this together is called as a GenAI. Okay, so there is no hierarchy, but rather there is a more of a interconnected and overlapping structure to it. Okay, thank you very much, everyone. Sorry if you guys had any trouble in the session, but overall, I'm hoping the session was good and helpful to you. Take care. Best of luck to everyone.